IAM policy types explained. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. Identity policies, trust policies, permission boundaries, session policies, and resource policies are 5 distinct IAM mechanisms that control authorization in AWS. They operate at different stages, use different logic models, and serve different purposes. Understanding how each works and when they are evaluated is fundamental to mastering AWS IAM security. Let's start by examining the first flowchart for identity policy. Identity-based policies are the foundational policies in IAM. They are attached directly to IAM users, groups, or roles and define what actions those identities can perform. At the top of the flowchart, we have the IAM user or role node representing an identity attempting an action. An arrow flows to the identity policy evaluation box where AWS evaluates all policies attached to the identity, including inline policies and managed policies. From there, an arrow flows to a decision diamond labeled policy allows action. AWS determines whether any attached policy has an explicit allow statement for the requested action on the requested resource. If no policy allows it, the check returns no and flows to a red denied node labeled implicit deny no allow statement. This represents the default deny principle in AWS, where everything is denied unless explicitly allowed. If a policy does allow the action, the check returns yes and flows to another decision diamond labeled policy has explicit deny. AWS checks for explicit deny statements because denies always override allows. If there is an explicit deny for this action, the check returns yes and flows to a red denied node labeled explicit deny overrides all. If there is no explicit deny and the check returns no, the flow proceeds to a green allowed node labeled action permitted by identity policy. The note at the bottom emphasizes that identity policies grant permissions and explicit denies always win. Now let's examine the sequence diagram for identity policy, which shows the numbered interaction flow. The diagram has 5 participants: user, AWS service like EC2, IAM authorization, identity policy, and target resource like S3 bucket. The sequence begins with step 1 where user sends a PI request to AWS service. In step 2, AWS service forwards authorize request to IAM authorization. In step 3, IAM authorization sends check all attached policies to identity policy. Identity policy evaluates all policies and in step 4 returns policy evaluation result to IAM authorization. The diagram shows an alt box with 2 paths. In the allow path, step 5 has IAM authorization send authorization granted to AWS service. Step 6 has AWS service send access target resource to target resource, and step 7 has target resource return action successful to AWS service, which in step 8 returns success to user. In the deny path, step 5 has IAM authorization send authorization denied to AWS service, and step 6 has AWS service return error access denied to user. The note emphasizes that identity policy is the foundation, evaluated for every API call. Moving to trust policy, the flowchart shows how trust policies control role assumption. At the top, principal wants to assume role flows to role trust policy evaluation where the role's trust policy is checked. A decision diamond asks trust policy allows principal. If no, it flows to red access denied cannot assume role. If yes, it flows to green assume role success principal gets credentials. Trust policies are gatekeepers that determine who can assume a role. The trust policy sequence diagram has 4 participants: principal, AWS STS, IAM role, and trust policy. Step 1. Principal sends assume role request to AWS STS. Step 2. STS sends retrieve role details to IAM role. Step 3. Role forwards check trust policy to trust policy. Step 4. trust policy evaluates the principal. In the allow route, Step 5 has trust policy return principal authorized to role. Step 6 has role send generate credentials to STS. And Step 7 has STS return temporary credentials to principal. In the deny route, Step 5 has trust policy return principal denied to role. Step 6 has role send trust policy violation to STS. And Step 7 has STS return error access denied to principal. The permission boundary flowchart shows how boundaries set maximum permissions. At the top, IAM user or role with boundary flows to identity policy grants permissions. Then to decision diamond permission boundary allows action. If no, it flows to red action denied boundary restriction. If yes, it flows to green effective permission granted identity policy and boundary. This is intersection logic where both must allow. The permission boundary sequence diagram has 5 participants: IAM user with boundary, AWS service, IAM authorization, identity policy, and permission boundary. Step 1. User sends API request to service. Step 2. Service sends authorized request to IAM. Step 3. IAM sends check identity policies to identity policy. Step 4. Identity policy returns action allowed in policy. Step 5. IAM sends check permission boundary to permission boundary. Step 6. Boundary evaluates action. In the allow path, Step 7 has boundary return boundary permits action. Step 8 has IAM calculate intersection. Step 9 sends authorization granted to service. And Step 10 returns request successful to user. In the deny path, Step 7 has boundary return boundary blocks action. Step 8 sends authorization denied to service. And Step 9 returns error to user. The session policy flowchart shows optional session restrictions. Role assumed flows to decision session policy provided. If no, it flows to green full role permissions apply. If yes, it flows to calculate effective permissions role policy and session policy. Then to green restricted session permissions apply. Session policies only restrict. The session policy sequence diagram has 5 participants: user, AWS STS, IAM role, session policy, and AWS service. Step 1. User sends assume role with optional session policy to STS. Step 2. STS sends validate trust policy to role. Step 3. Role returns trust check passed. In the session policy provided path, Step 4 has STS send apply session policy to session policy. Step 5 has session policy calculate intersection. Step 6 returns restricted permissions. Step 7 has STS return credentials with limited permissions to user. Step 8 has user send API request to service. Step 9 has service evaluate restricted permissions. And Step 10 returns result to user. In the no session policy path, Step 4 has STS return credentials with full role permissions. Steps 5 through 7 show the API request flow with full permissions. The resource policy flowchart shows union logic. Principal requests resource access flows to decision identity-based policy allows. Both yes and no paths flow to decision resource policy allows. If no, flows to red access denied. If yes, flows to green access granted identity or resource policy. This is union logic where either can grant. The resource policy sequence diagram has 5 participants. Principal from account A, AWS resource in account B, IAM authorization, identity policy, and resource policy. Step 1. Principal sends API request to resource. Step 2. Resource sends authorized request to IAM. Step 3. IAM sends check principal identity policies to identity policy. Step 4. Identity policy returns policy result. Step 5. IAM sends check resource policy to resource policy. Step 6. Resource policy evaluates principal. In the allow path, Step 7 has resource policy return access granted. Step 8 shows IAM note about union logic. Step 9 sends authorization successful to resource. And Step 10 returns request successful to principal. In the deny path, Step 7 returns access denied. Step 8 sends authorization failed to resource. And Step 9 returns error to principal. The comparison table shows 5 policy types. Identity policy grants permissions to identities, evaluated during all API calls, attached to IAM user, group, role, yes can grant permissions. Trust policy controls who can assume roles, evaluated during assume role, attached to IAM role, specifies principals. Permission boundary sets maximum permissions, evaluated during all API calls, attached to IAM user or role, no only restricts. Session policy restricts session permissions, evaluated during assume role when provided, attached to role session inline, no only restricts. Resource policy controls who can access resource, evaluated during resource access, attached to AWS resource, yes can grant cross-account access. The code examples show all 5. Identity policy allows EC2 and S3 actions for specific user. Trust policy allows specific user to assume role. Permission boundary limits to development resources with tag condition. Session policy restricts to read-only S3 for specific bucket. Resource policy allows cross-account access to shared bucket from account number. Thank you for your attendance. Please consider subscribing to the channel and liking this video.